Hello guys, welcome to the next lecture on the PY question series. Today we will discuss about Bessel's and Legendre functions. Based on your several requests, I choose this topic as the Bessel and Legendre function. Myself Dr. Harish, you can simply follow my YouTube channel where you can find the two playlists. One is the Gate of Mathematics. Here you can find the PY questions as well as the topic wise related to the CSR net and the gate examinations with the help of shortcut tricks. There is one more playlist which is related to the CSR net and which will helpful for you to crack the CSR net examination in a very simple manner. And you can see a latest December 2023 and many more lectures available here. So before I start with directly to the PY questions, as I mentioned you, I always give you the tips as well as some shortcut tricks. You can solve this, you can remember this to solve the problem. I hope you can like, share and subscribe this video to your friends as well. So what is the Bessel function? If you have the Bessel function of the order n, I can define like here. On the other hand, the Legendre function, it is defined like this way. Make sure you can easily remember that the derivative of this should be of this nature. Now whenever you are trying to solve this Bessel function or Legendre function, the solution of the Legendre function is my p of n x. And that p and x you can easily obtain by using this formula. I think all of you know that this formula is the Rodrigues formula. For example, if you substitute n is 1, you can get as the value of p1 is 1, p2 is here and so on. Now from here you can clearly say that what is the odd, if you look about the odd numbers 3, 1, 5 and clearly says what will happen if you substitute x is 0, the value will be 0. What will happen of the P5? It will be again 0 and so on. So the first remark is whenever n is my greater than or equal to 1, this even number, that is my here, this, and clearly say these are my even number. Why? You can clearly say P of minus x is my P of x. However, when you consider as the odd numbers, this is always my odd function. So what does it mean? If I integrate P3 from minus 1 to 1, it's a 0, or when you integrate from odd number, it is always be a 0. So that's a very important concept for you. And as I told you, if I substitute odd number, it's a 0, and if I substitute even number, it will be my minus 1 over 2, it will be my 3 over 2, P5 is my 0, P6 will be my minus 5 over 16 and so on. So that's a simple remembrance. Now apart from that, these are the values at the 0, but if you want to find the values at the 1, then it is always 1. However, if you consider as a minus 1, then it will be depending upon the minus 1 raised to power n. P of n, that is a solution of the Legendre polynomials, are always orthogonal to each other. So that means whenever n is equal to m, it will be 2 over n, 2n plus 1. Make sure the limits are from minus 1 to plus 1, otherwise 0. It's a very important concept. When you multiply this polynomial solution by any of the polynomial, then it will be 0 when this m is less than of Pn. Otherwise, it will be non-zero. And if you write any of the function, any of the f of x in terms of the linear combinations of Legendre functions, then you can find that coefficient by using this formula. So based on, that's a 2n plus 1 or 2i plus 1 over 2, that's basically a this factor, it's minus 1 to 1 f of x into pi x. Now based on these simple tips, I can show you, you can solve each question in a very simple manner. The most important thing is you must remember first 4, or moreover the first 3, you must remember the first 3 definitions of these PIs. Once you can remember this, I can solve all those PY questions in a very simple manner. So like, I hope you can like, share and subscribe. Let's start with these PY questions. So you may join my WhatsApp group for the various discussions and the shortcut tricks. So let's start with the first one. The first question says it's a Legendre polynomial. So that means your PIs are my orthogonal. It means PI into PJ is my 0 and whenever I is not equal to J. Now you can see that if you look about minus 1 to this summation part and the whole square, when you open this summation, it will be look like say here, fine. And when you open the square, if I call this is A, B, C, it will be A square plus B square plus C square plus 2ab, and now because of this orthogonal property this value will be 0. Similarly for the other terms, so I can open this bracket as, and this I can return this, n is my summation will be outside, and the remaining part will be minus 1 to plus 1 of square. So what is the square of this is 2j plus 1 of pj square. That's over. Fine. Now we have to integrate with respect to x, so this value will be constant, it come to be outside. So what is that? J 2j plus 1, and the remaining part is integration of the pj square. And what is the integration of the pj square? 2 over 2n plus 1, n is my 1, so 2n plus 1 is the right answer. So 2 will be this, so 2 is outside, summation of the j from I is equal to 1 to n. So what is the answer of this? N plus 1 over 2, and they are given to you as a 20. So can you get the answer? Like, look at the 2 into 3 is 20, not possible. 3 into 4, not possible. 4 into 5, 20 possible. 5 into 6, 30, not possible. Right answer is my C is the correct answer. Look at this next question. The Legendre polynomial is here, P1 of x is this, and you have to find the value of n. Very simple. I will tell you the two different approach. Choose n is equal to 1. Fine. So then this equation will be P of 3 dash minus P of 1 dash is alpha 1 of P2. Fine. And we all know what is my P1x. P1x is my 1x. P2x will be my 3x square minus 1 over 2. P3x, it will be my 5x cube. As I told you, you always remember the first two values. Now you can check the values at x is equal to 1, any value, because the initial value is given at the 1. So what is the derivative of this? It's a 15 minus 3 over 2. What is the P1 dash? It's a 1. Alpha 1. P2, what is the value of the P2 at x is equal to 1? 3 minus 1 over 2. So what is that? It says 6 minus 1 is alpha 1. So alpha 1 will be my 5. Now look at the option. When n is equal to 1, because I consider n is 1, this is not 5, this is not 5, this is not 5, this is 5. So the right answer is my D is my correct answer. There is one more method. What is that method? If you remember that recurrence, if you remember the recurrence relation of the Pn, what is the recurrence relation is? The derivative of Pn minus Pn minus 2 is equal to 2n minus 1 of Pn minus 1. Now if you compare them here, you have to replace n to be n plus 2. So this is my alpha n. So what is my alpha? I have to replace n to be n minus 1. So 2n plus 3 is the right answer again. But in that case, you have to remember this recurrence formula. But I told you there is no need of them. You can simply start n is equal to 1. You may start from the n is equal to 2. That's on your choice. But always choose the number which is much easier. Okay. Remember, one tips I forget to tell you. Whenever the initial solution is given to you, then remember, initial solution, whatever the solution of this, that is a constant times the polynomial solution. This is always, whatever the solution of the Legendre, this is the Legendre equation, fine. The solution is always the constant times the Pnx. Now what is given to you? Firstly, you have to find the n. You can see if you compare this, this is my 6. Make sure the coefficient of this is a 1. So can you find the value of n? N is 2. Let's say 2 into 3 is 6. So it means my y of x is alpha times P2x. Now constant is already given to 2. That means 2 times P2x. This is my solution. Fine. Now I can substitute here. What is the answer of this? 4 is outside. It's a P2 square. Fine. Now what is the solution of the P2 square? It is 2 over 2n plus 1. So n is my 2. So it's a 4 plus 1. The right answer is 8 over 5 is my right answer. always remember whenever you have to find, whenever the initial condition is given to you, you can find this approach, alpha times whatever the n you have obtained. Now again you can see the initial condition is given to you, so your solution will be y is equal to alpha is my 3 and p of n. So now you can see n is not given to you, so there is no issue. This is my solution. I can substitute here. So what is that? 9 will be outside, 1 to minus 1 p n square plus again 9 is outside, but n will be my n minus 1 square. It comes to be 144 divided by 50. Now what is the right answer of this? It's a 9 into 2 over 2n plus 1 plus 9 2 over 2n, because n in this case is n minus 1. So the numerator is 18, 18 can be cancelled out, so it will be 2n plus 1 and it is 2n minus 1, it is 8 over 15. So or you can simplify it, this is a 4n square minus 1, it is 4n is 8 over 15. Now there is no need to solve, I can check about the option. When n is equal to 1, it will be 4 over 3, which is not equal to 8 over 15. So this option is cancelled out. When n is equal to 2, 8 is a 16 minus 1, 15 is a correct option. When n is equal to 3 is a 12, is a 3, 9, 36 minus 1, 35, it is not correct option. Similarly 16 and this is 64 minus 1, again it is not right answer. B is my correct answer. Now you can see this is my Bessel equation. Fine. Make sure the coefficient should be 1. So if you compare the Bessel equation plus x y dash plus x square minus n square. So this n is my order. So can you find the order of this? It is 3 over 5. Now n is 3 over 5. So now we all know the Bessel function has the solution Jn and Yn. But here they have written only in the Gn. So what is that? It's a very simple, it's a 3 over 5. So it's a 3 over 10 because n is my order. It's a 3 over 5, it's a 3 over 10 cancel. Now whether say x or 2x, if you compare what is my x, in this case you can see I can return this as 2x the whole square. Now this is the x, so it will be 2x. So this is the right answer. This is a wrong answer because the solution will be j of n 2x plus c2 yn, but I can return in terms of the negative. It's a minus n of 2x. Here n is my 3 over 5 and minus, so A is my correct answer. Look at the next one. P of n is my Legendre polynomial of degree n. N is not given. Okay, now 1 to minus 1 x raised to power k p of nx into dx. This is my I. Fine, where k is a non-negative integer, which of the following statements are correct? Okay, as I told you in the earlier tips, whenever k is a polynomial of degree k is less than of this n, what is the answer of this? It is always 0, and it is non-zero whenever k is equal to n. So if he said k is less than n, it is always 0. So that means this is my correct statement. Fine, this is the first method. Otherwise, if you forget this method, again a very simple, what you can do, you can choose any value of the n and k. K is my non-negative, so I can choose k is my 1. Fine, choose as simple as here. And what is the value of n is degree, n is my 2. So what is my I? 1 to minus 1 x p2x. What is the p2x? As I told you, you have to remember only the two cases. Fine. So this is my 3x square minus 1 over 2. Now there is no need to solve them because this is my even function, this is my odd function. So when you integrate them, it will be 0. So this is my correct statement. Now it will be 0 if n minus k is an odd number. Again you can see that. What is the n minus k? N minus k is my 1. So which is an odd number, again it will be the 0. So this is also my correct statement. So both A and B, P and Q are my correct statement. Okay, look at this next one. This is a Bessel function of this identity given for all t greater than 0. The value of this is equal to. If you closely look about this function is independent of t. Fine, because this function is dependent on the t, this is independent of t. So that means you can choose the value of t as per your own convenience. You may choose t as a 1, you may choose t as a 2, you may choose t as a 3. So but the simplest one is I can choose t is equal to 1. So if I substitute t1 here, what will happen? This is 1 minus 1 0, so e raised to power 0. This will be j0 of x plus is a summation of j of n x. It will be 1 plus minus 1 raised to power n, where n varies from here. Now your target is to find the pi by 3. So what is the value of the pi by 3? It is a 1, which is j0 pi over 3, and clearly say this value becomes my 0 if n is my odd, and it's a 2 when n is my even. So I can simply taken as a even number. Fine, so it will be my twice of jn at pi over 3, and you can see it is the same of this. 2n is always, so what is the answer of this? Answer is 1. Always try to think, read the statement carefully. Whichever is you don't require, substitute the value as much simple as you can. Okay, this is again the initial condition is given to you. So my solution of this will be is a 1 into p and x. So what is the n? You can compare this. N into n plus 1 is my 6. So what is the n? 2 into 3. N will be my 2. So my solution of problem will be 1 into p2x. Then I can substitute here minus 1 p2x into x plus x square. So I can open this bracket. It's a x into p2x plus 1 into minus 1 x square into p2x. Now because we all know what is the p2. P2 is my 3x square minus 1 over 2. Now you can see this is the even function. This is my even, this is odd. So the answer of this will be 0. Now for this case, it is a even and even. So I can write it as a twice of this function. So I can take 1 over 2 outside. 0 to 1 x square 3x square minus 1. Fine. Now that's over. It will be cancelled out 1. What is the integration of this? 3x raised to power 4. So 3 over 5. X square is a 1 over 3. So what is that? 9 minus 5 over 15. So 4 divided by 15 is the right answer of this problem. So you can divide them. Whatever the answer will be here, you can write up to 2.6667 will be the right answer. You can see that it's a very simple approach. You can solve this. The major problem is how you can identify the solution. Another way you can think about that. Again, you may use this formula k p of nx. It will be 0 if this k is less than of the n, and you can see this is a 1 is less than of the 2, so this answer will be 0, or otherwise even and odd concept you can apply that, and they are equal, it will not be 0. Okay, now second one is now again the Bessel function j of this. So your target is to find the 3 by 2. What should I substitute? I can substitute alpha is half. Fine. So this value will be minus half, add the value of x plus 3 by 2 of the x. When alpha is half, it will be my 1 over x j of half x. And we all know what is the standard value of the j positive half and j negative half. So what is the j positive half? It will be 2 over root pi x into sin x, and j of minus half of the x will be 2 over pi x cos x. Now I can substitute the value. What is the j? And now at pi. So at x is equal to pi. So j of my, this value will be 0, sin pi will be 0, this value will be negative of 2 over pi x. So j positive will be 0. So this value will be 0, this value will be minus 2 over pi x, x will be pi, plus this value I need to calculate, at the pi is my 0. So j 3 by 2 of pi is my root 2 divided by pi. So I can substitute here, it's a pi into this. So what is the answer of this? I think now it's a very simple, you can scare them, it will be my 2 is the right answer. How many seconds you are needed to solve the problem? Just always look at the statement carefully. I hope you can like, subscribe and share my channel too. Okay, phi are my orthonormal. What is orthonormal means? That means phi I into phi j is my 0 whenever I is not equal to j, and phi I whenever I is equal to j it will be 1, and such that this property holds. Cn is my constant, Pn is my Legendre polynomial of degree n, and here okay, Cn is my constant because whenever I substitute 1 I need a, fine, I can use this property. It means phi n square it will be my Cn square, Pn square. Now I can integrate them. This value will be my 1, it will be Cn square. I can integrate over the domain minus 1 to 1. What is the Pn square over minus 1 to 1? 2 over 2n plus 1. So what is my Cn? Cn will be here. Fine. So therefore my phi of n is 2n plus 1 over 2 into Pn. Now that's over. Now I can check about the first option. What is the phi of 6 at 1? N is my 6. 16 is a 12 plus 1 is a 13 over 2 into Pn of 1. So what is the P of n1 is? P of n is 1 for all n. Fine. So this value is my root 13 divided by 2. So this option is cancelled. Phi of 7 minus 1. What is the phi of 7 is 14 plus 1. 15 by root 2. P of n minus 1. Okay, what is the, as I told you earlier, what is the P of, is minus 1 raised to power n. So what is the n? N is my 7. So 7 is a minus 1. So it's a minus root 15 over 2. But he said 1. Phi of 7 1. What is the phi 7 is? 15 over 2. And P7 of 1. P7 plus 1 is 1. So it's a right answer. Phi of 6 minus 1 is a 13 over 2. And P of 6 minus 1. So when n is equal to 6, it's my plus 1. So this is my 13 over 2 is the right answer. So C and D are my correct answer. You can see that it's a very simple approach. If you remember, you can watch it completely, understand it completely. You will solve each problem within a 10 to 15 second time period. Okay, look at this one. P of n is a Legendre polynomial of degree here. Then x raised to power 10, which will comes to be the summation of this Pf and x. If you remember that, what I gave you the earlier tips, if you write this as the linear combination of here, how you can find the value of the Cn? It's a 2n plus 1 over 2 integration from minus 1 to 1 fx pnx. Fine. Now what you want to find? You need C5. So what is the C5? 10, 11 over 2 minus 1 to 1 fx will be here. This is my fx and P5. Fine. Now either you can find the value of P5 or otherwise there is no need. You can see that this is my even function P5 because it's a 5 is odd number. This is my odd number. Always remember P of nx is my odd function if n is odd. If n is odd, and it is a even when n is even. So it's a odd, this is even, and integrate from -1 to 1 is my 0. So C5 will be my 0, is my right answer. How many seconds again you are needed? I hope you can like it. Okay, look at this another one. Again you can see I can write this value as AI PI. Fine. So very simple. Now what do you want to do? A0. What is the AN formula is? 2n plus 1 over 2 minus 1 to 1 fx pnx. Fine. So when you write A0, it will be my half. 1 to minus 1, what is the fx is? Here I can write it. What is a P0? So what is a P0 of x? It is always a 1. Fine. So what is the answer of this? I can written fx is here. So -1 to 0 minus x. So what is the integration of this? Minus half is common. It's a x square over 2 from 0 to -1. So what is that? It's a minus half, 0 minus, so it's a plus 1 by 4. So A0 cancel, this is cancel, this is cancel. Only left behind is my B is the right answer. If you want to calculate A1, I can do for you, but there is no need. What is the A1 is? 3 by 2. Again, I can break them from -1 to 0. Fx is my here. What is the P1x? P1x is my x. So I can written here x. So it's a minus x square. Integration of the x square is x cube over 3 from -1 to 0. So I can say this number 0 minus -1 over 3, and you can clearly say it will be my, it's a minus, where is the mistake? It's a positive, it's a -1 over 2. Where is the mistake? A3 fx is my minus x, so minus is outside, x square x cube by 3 0. So that's it's a minus. It will be the -1 over 2. Otherwise none of these is the right answer. If it is a positive, then it's a minus, -1 by 2 is the right answer. Okay, for the Legendre polynomial here, so my P of n x is given to you as Cn, nth derivative of, this is not a y, it's a x square minus 1 of n. So I think that's all of you know that this is the Rodrigues formula, and you know what is the Cn. Cn is 1 over n factorial, so that's the right answer. But what will happen if you forget in the examination? So again, as I told you, take n is equal to 1. Left hand side will be P1x. It will be my C1, first derivative of x square minus 1. What is the first derivative is? 2x. What is the P1 is? X. So what is the answer of the C1? C1 will be 1 over 2. So if I substitute n is equal to 1 here, it will be 2 over 1. So this option cancel, this option cancel, 1 over 2, that may be correct, that may be correct. Now choose n is equal to 2. What is the P2x? It will be my C2, second derivative of this. So what is the first derivative is? Sorry, it's a x square minus 1 square. Fine. Now what is the first derivative of this? It will be 4x into x square minus 1. What is the second derivative of this is? It's a x cube. It's a 12x square minus 4. What is the P2x is? 3x square minus 1 over 2. I can take a 4 as a common. It will be cancelled out. So this value will be cancelled out as a 4. So C2 is 1 over 8. Now you can see when I take n is equal to 2, it is a 2 factorial. It is 1 over 2. It is a cancel out. It's a 1 over 2 factorial. 2 square. It is a 1 over 8 is my A is the correct answer. Always choose the particular value of the n. You can solve it as per your easy convenience. Okay, look at that. Y and G are the solutions of the Bessel function. X square y double dash x y dash plus x square minus n square of y is equal to 0. Of the first order and second order, then the solution of this will be. So I need a j1, y1 and so on. Fine. There is no need to solve them. I can choose the first solution as here. So say I can choose y is my x j1. I assume this is the solution of here. What does it mean? It will satisfy this equation. Fine. So what is the second derivative of this? I can take the first derivative plus j1. Fine. It's a minus x j1 dash plus j1 plus x of y is a x j1 is equal to 0. I will check whether it's a 0 or not. So again I can find the second derivative x j1 double dash plus j1 dash plus j1 dash minus x j1 plus x square j1. So what will happen? It is a x square j1 double dash. This value will be cancelled out from here plus x j1 dash minus 1 and here plus x square minus 1 of j1. Does it equal to 0? Clearly says that j1 satisfied here, because what is the meaning of the j1? N is equal to 1. So it means this is 0. Why? Because j1 is the solution of Bessel function. Fine. So it means this satisfied. If j1 satisfied, definitely y1 is also satisfied. So yes, this is my solution. Fine. So rest of the option you can easily discard it, because only A option is the correct option. Okay, look at this one. It's again a Legendre equation. So this 30 is basically a n into n plus 1. Can you find the value of n? It's a 5 into 6. Fine. So n will be my 5. Now y is equal to the boundary solution of this. So what is that? Solution is my p5x. So what is the first part? First part will be minus 1 to 1 x square p5x. Fine. Now it's a 0. Why? Because 2 is less than of 5. Fine. But he said not 0. So this option is cancelled. Look at the second option. 1 plus x cube plus x4 p5 again. So again it will be the 0, because 1 is, this is x raised to power 0. I can return 0 is less than 5. This first part 0. 3 is less than 5. 4 is less than 5. So each part is a 0. Again he said non-zero. X raised to power 5 of p5. Fine. Now since both the values are same, it will not be 0, but he said 0. So this option is cancelled. The last option is the pending one, is my right answer of this problem. Okay, look at this another one. The eigenfunction of this Sturm-Liouville problem, which are orthogonal to the weight vector of this. Okay, how you can solve that? We all know this is a general equation of the Sturm-Liouville problem into y is equal to 0, and from here what is my weight vector? Weight is my p. So basically my target is to find the value of p. So I can firstly write this equation here, y double dash plus r dash y dash plus q plus lambda times p of y is equal to 0. Now you can see the coefficient of this is a 1, so I can make them to be a 1. Y double dash r dash over r plus q plus lambda p over r into y is equal to 0. Now I can compare this equation with the help of here. So what is the r dash over r? It is a minus 3. It's a coefficient, it's a right hand side, so I can say this is a minus lambda is equal to 0. So what is the coefficient of the y? Minus lambda. So it means p over r is my minus 1 and q over r is my 0. Fine. So my target is to find the p. It means my target is to find the r. So what is that? It give you r is e raised to power minus 3x. If I substitute here, p will be minus e raised to power 3x. So minus is a constant, So e raised to power 3x is the right answer. Rest options are, because 3 minus is a constant, so it is a, this is also a weight vector, 12 is also the weight vector, 42 is also the weight vector. Right answer is my A is the correct option. Okay, look at this another one. Pn is a Legendre polynomial of here. So this will be, so what is that? It will be nothing but 2 over 2n plus 1. So the my only target is to find n. So we have to find n such that p of n0 is my 5 over 16. So definitely look at that. As I mentioned you earlier, p of n0 will be 0 if n is my odd, but here is a non-zero, so definitely n will be my even. Fine. If n will be my even, then 2n plus 1 is my odd, so this is my cancel. Fine. Now rest of the options are there, so we can check about either from the option. If this is the right answer, then n will be my 6. If this is the right answer, then n will be my 4. If this is the right answer, then n will be my 2. Fine. So look at that. What is the p2x? p2x will be 3x square minus 1 over 2. So if n will be my 2, it means p of 2 0. What is the p of 2 0? Minus half, which is not equal to minus 5 over 16. So this option is cancelled out. What is the p4? Okay, how you can find the p4? You can see from here. If I substitute n3, so p4 0 3 over 4 and 3 minus 1 2. So what is the p of 0? Is a minus half. It is my 3 over 8, which is not equal to 5. So this option is also cancelled. So this is my p4. Now I can find the p5 by when I substitute m is 5. Fine. So what is that? It's a p6 0, because only one left option is there. So A is my right answer, but we can verify it for you. N is 5 and p4 0. So what is the p4 0? Is 3 over 8. So if I multiply this into 3 over 8, so you can see, so it is minus 5 over 16 is the satisfied. So n will be my 6. If I substitute here, your right answer is A is my correct answer. Otherwise you can simply discard the option. You can easily discard the option, you can get the right answer. Okay, don't forget to like and share and subscribe my lecture. Again you can see a polynomial with the constant coefficient. A polynomial is a solution, so it will be 1 into p and x. Fine. If it is a 4, I can written as a 4, but right now it's a 1, so I can written as a 1. So what is the n? N is my here. Fine. So what is the meaning of that? Y of x is basically a polynomial. And what is the degree of this p and x? We all know the degree of the p and x will be my n. So that means y is a polynomial of degree exactly n is the right answer. Fine. Look at the next question, which is the consecutive part of this. So as I got that y is the degree of, so y is nothing but p and x based on this initial condition. Then your I 1 to minus 1 y x n minus 3 p and x into dx, and the j option will be my 1 to minus 1 x raised to power n p and x dx. Okay, very simple. Can you solve this within 1 second? This will be 0 because n minus 3 is less than of the n, and they are same, they will not be 0. So I is my 0, j is my non-zero, j is my non-zero, I is my 0, j is my non-zero. So C is my right answer. How many seconds you are needed to solve this problem? Just a fraction of second. Again you can see the Legendre equation. So n plus 1 will be my 2. So clearly say n will be my 1. Fine. Now But here they are not talking about this. Now one solution is given to you. Okay, so firstly I can give you the tips. Whenever you have the equation of this py dash plus qy is equal to 0 and one solution is given to you as say u, fine, then you can find the second solution which comes to be u into v, where v is my integration of 1 over u square e raised to power minus p dx. Fine, that is a simple shortcut text for u. Now you can see the coefficient of this is 1, so I have to make them as a 1. So what is my v? What is the u? That is a one solution. One solution is given as a x. So this is the x square. E raised to power minus plus 2x over 1 minus x square. So what is the answer of this? It will be e of minus log of this. So I can written this as 1 over 1 minus x square. Fine. Now how you can solve them? You can factorize them. It will be 1 minus x square plus 1 over x square. So what is that? It will be minus 1 over x, and this will be 1 over 2a log of 1 plus x 1 minus x. So that is my v. Now if you multiply this by u, what will happen? This will give you the second solution. So second solution will be minus 1. So but he said a plus 1 is a plus 1, but he said only 1 plus x square. So you can see if I multiply by x is x over 2 ln of this, and you can see ln is a right answer. So fourth, that is a D, is my correct answer. Okay, you can see this is first one is my Bessel equation. Fine, the order is 1 over 2. I can compare this is n square x square minus n square. So order is 1 over 2. Have the two linearly independent solutions. Okay, which of the following is correct? I think all of you know that, because n is my half, which is not my integer. So it means, what does it mean? It means there are two Li solution. So first option is my correct option. Anyhow, there is one more method that's directly come in your mind. If you prove that this equation is my analytic around, what is the around this 0. If you prove that this is analytic, then it means this is my Li solution exists. How you can prove that differential equation is analytic? You can check about, I can write this equation is here plus 1 over x square minus 1 over 4 is 0. Fine. Now you can check about this singular point. So what I can do, if I firstly I can multiply this into px, and second is x square into qx. This is my qx. If the limit as x approaches 0 is my finite, if this is my finite, then you can say it's analytic. So what is that? Limit is my 1. If I multiply by x square, limit is my 1 by 4. It's a finite number. So yes, they are analytic around x is equal to 0. So once they are analytic, it means it exists. How many degree of this? 2. So it has 2 Li solutions. So the first solution is my correct option. Same concept I can apply for the second one. Again, I can find the solution around this. So what is that? I can firstly make it in a simple manner. It's a 3 sin x over x y dash plus y over x square is 0. So what is the limit as x approaches 0? X into px and x square into qx. Fine. So what is the answer of this? It will be, it's x square. Fine. So when you multiply them, it will be 3 limit x approaches 0 sin x over x, and it will be my 1. So which is a finite? That's fine. But you can see this is also a finite, but this 0 is my singularity. Fine. 0 is the singularity. What kind of the singularity here? It's a removable singularity. So once it's a singularity, what does it mean? It is not analytic, because it has a singularity. Once it's a not analytic, it means is there exist two Li? That's a wrong statement. So only P is my correct answer, while others not. Okay, look at this another one. What is given to you? Y is the solution of the differential equation x y double dash plus 1 minus x y dash plus ny is equal to 0. So clearly say it is it a Bessel function? No. Is it a Legendre function? No, because for the Legendre function we need a 1 minus x square. So do you remember that what kind of the function is here? This equation is called as Laguerre equations. Fine. And the solution is denoted by ln, and it comes to be e raised to power x nth derivative of e raised to power minus x into x raised to power n. This is the solution of this. And as compared to this orthogonality, it is orthogonal ln into lm e raised to power minus x from 0 to infinity dx. It's come to be my 0 if n is not equal to m, and 1 if n is equal to m. So you can see that they are asking you this is equal to 0 only when n is not equal to m. That means p is not equal to m. What is the, for which of the function weight? This is my weight. Fine. So e raised to power minus x is the straightforward solution of this problem. Okay, look at this another one. Again you can see one initial condition is given to you. So my solution will be of 5 p of n. Now it's a k, so I can say it's a p of k. Fine. Now k is not given to you. You have to find the positive value of the n. For which value of the n this equation satisfied? Again, because they are the Legendre polynomial, I can use this orthogonal property. It will be 0. Fine. Now you can see if I open this a minus b whole square, it will be like a square plus b square minus 2ab. By using this property, it will be cancelled out when you take minus infinity to here. So it only has a square plus b square. I have written half is outside. I can take summation is outside. Fine. And then minus 1 to 1 of yn yk square. Yk is my 25 pk square plus 25 pk minus 1 square. Fine. This is my first part. Minus. Look at this one again. Yk is my 5 into pk. Summation I can take as outside. 25 is outside, is a pk square, which is come to be 25. Now you can substitute the value. 25 I can common it. 25 over 2. Summation of, what is the solution of this is 2 over 2k plus 1, plus the solution is 2k minus 2 plus 1 is a minus 1. Again 25 into 2 over 2k plus 1, and it comes to be the summation. It is 24. Now what is that? 2 will be common, that's a 50. No, it's a 2 will be cancelled, 25, and I can take as a 50 common, or it will be 25 summation of 1 over 2k plus 1, 1 over 2k minus 1, and it will be 50 of 1 over 2k plus 1 is 24. I can take 25 as a common. Fine. So what will happen? It will be the double of, and it will be here. So I can return this number as 2k minus 1. Based on this and this, it will be minus 2k plus 1. It will be 24. Fine. Now what is that? If you open this, it's a 1 to n. The first term will be 1 minus 1 over 3, then 1 over 3, 1 over 5, and so on. The last term will be 2n minus 1, because summation is ending at n minus 2n plus 1 of 25 is 24. So which one is the cancel? So every term is cancelled. First and the last term will be pending. So 25, 1 minus 2n plus 1 will be 24. I think that's over. If I open this, 25 minus 24 is 1. 1 of 25, 2n plus 1. So clearly say n will be my 12. 24 plus 1. So n is the 12 is my right answer. So always remember, whenever this initial condition is given to you, you can write this in this polynomial function. So this is the way you can solve all these questions of the Legendre and the Bessel function in a very simple manner. I hope you can like, you can subscribe and share my video with your friends. I hope we will see in the next lecture related to the numerical analysis. Till now, you can simply like, share and comment on videos. Best of luck, students. Happy learning.